Hi guys, and welcome to today's video on matrix arithmetic, the product of two matrices. It is awesome to see you. Thank you very much for dropping by. Now, have you watched the previous videos? No? Well, this is part of a series on matrices, which is building towards the really funky stuff in the next few videos. We've already looked at adding, subtracting, and multiplying by a scalar. Now we're going to multiply two matrices together. There is a trick to all of this, and sadly, a lot of people find this quite challenging. You're not going to, because I've broken this down step by step by step, and fingers crossed by the end of this, you will be a gun at matrix multiplication. Now, being able to multiply two matrices are really important, but we don't want to waste our time doing it if it can't in fact be done. So there must be a simple check, and in fact there is. This is where the order of matrices becomes really, really important. Do you remember that order stuff where you have the number of rows by columns and rows by columns? Now, to multiply matrices together, this is the official wording. You can only multiply matrices where the number of columns in the first matrix equals the number of rows in the second matrix. Basically, what they're trying to say is when you write this down, is that outer number there the same as that number there? So when you put these two orders side by side, are the two middle numbers the same? If they are, I'm telling you, it can be done. Ka-ching! Now, that's not telling you how to do it. It's just telling you it can be done. Because again, we don't want to waste time doing this if it can't be done. What about these two matrices behind me? So we've got a 2 by 2 and a 3 by 2. So let's do that quick check. Those two middle numbers there, are they the same? No. So in this case, it can't be done. And unfortunately, further maths has got to have that random language, thank you, Barry, where we have to say that the product is undefined. Now, product in maths just means times, and undefined means it can't be done, governor. Sorry, mate. Moving on. All right, so there we go. So in this situation, those two matrices could not be multiplied together. Now that we know that they can be multiplied, how do we then multiply them? Hold on, we're getting there. Wouldn't it be nice if we also knew the size of the matrix we were going to get as an answer, the order of this? Well, actually you can. The byproduct of doing this 2 by 2 by 2 by 3 actually gives us the order of our result. So I'm just going to write this as 2 by 2 and 2 by 3. So again, the check is those are the same, they are. Well, the good news is that this and those two values actually have importance, because they're now telling me that when I multiply these together, I'm actually going to get a 2 by 3. Remember, that's 2 rows by 3 columns. So 2 rows by 3 columns. And so we'll have 1, 2, 3 numbers there, 1, 2, 3 numbers there. How are we going to get this? I'm going to show you now. Right, so let's start something relatively simple. I'm going to do a 2 by 2 and a 2 by 1. So let's just check they can be multiplied. I've got a 2 by 2 and a 2 by 1. I'm not going to write the word by, I'm going to do times because I pretty much understand what it means. Yes, those two middle numbers are the same. What is my outcome going to be? It's going to be a 2 by 1 matrix. So what's that? 2 rows by 1 column. So I'm going to end up with looking for 2 numbers. Good, it can be done. How do we do this? Well, we actually do it in order. So we multiply rows and columns together. Step by step, I'm going to show you how to do this. So the first thing we do is we multiply row 1 by column 1. So row 1 by column 1. And then we do row 2 by column 1. Row 2 by column 1. Now you're going to say, how do I know that? Let's go back to my answer. We know that this is going to come out as a 2 by 1. So let's look at this element here. What is the subscript of that element? It is 1, 1. What is the subscript of this element? Remember, it's row by column, so it would be 2, 1. Oh, hold on. Do you notice the link? Well, element 1, 1 means row 1, column 1, and element 2, 1 means row 2, column 1. So now we've got a link between the element and the row and column we're going to do. Oh, this is awesome. So basically what we do is we pair these things together. Let's look at the first row. So we've got the first row and the first column. As we move along a row, we move down a column. And so I'm going to write my numbers as 10 times 5. So I've paired the first number on the row and the first number on the column. And I'm going to pair the second number on that row and the second number on that column. And I simply add them together. Why? Who knows? Who cares? To be perfectly honest with you, it just works. Now what do I do? Well, I do 10 times 5 is 50, plus 4 times 2, which is 8, which gives me the staggering value of, 58. And remember, because I'm doing row 1 times column 1, it goes in element 1, 1, 58. What do we do now? Well, I'm going to copy that value down because I'm going to forget it otherwise. And so we now move on to the next row and column. So we've got this row and this column. So bearing in mind we do the first number and the first number paired, which is 9 times 5. The second number and the second number paired, 3 times 2. And we add the result of those together. So 9 times 5 is 45. 3 times 2 is 6. And that gives me the staggering value of 51, which we write there. Why? Because we are on row 2. Column 1, we want element 2, 1, which is that element there. And ka-ching, we have our final answer. Yay! And let's ramp up the complexity just a little bit. We'll now do a 2 by 2. Does it get any more complicated than this? Maybe, maybe not. Possibly, possibly not. But it doesn't actually matter so long as you work out the process which we are following now. Okay, so let's see. Firstly, can we check that they are going to be multiplied? We can indeed. So that is a 2 by 2 and a 2 by 2. So are the middle values the same? I should cocoa, and then the outer values tell me the order of my matrix. There are going to be a 2 by 2, so 2 rows and 2 columns. So let's just look at the elements we have. We have 1, 1, followed by row 1, 2, and then we have 2, 1 and 2, 2. So this suggests we're going to do row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. All I'm doing is reading these element numbers, and as we can see, I've even put this in the notes for you, all downloadable from MaffsGuru.com. So row 1, column 1, element 1, 1. So let's actually do that. Let's do this in 4 different stages. So row 1, oh, he says. So row 1 and column 1, let's multiply those together. So pairing the numbers gives me 1 and the 3 multiply together, and then we do the 3 and the 4 multiply together. As we move along a column, as we move along a row, we move down a column, and then we add the results together. 1 times 3 is 3, 3 times 4 is 12, add them together gives me 15. So there we go, there is my first result, 15. Let's copy it down, because we're now going to do the next one. So 15 is in there. What do we do next? Well, as we say, we're now going to get this element here. Why do we do that element, not the others? You can do whichever element you like, so long as you multiply rows and columns together. Okay, so what are we doing? We are doing row 1 and column 2. All right, so moving across, we get 1 times 5. Yep, first number, plus the second number, 3 times the second number of 2. 1 times 5 is 5. 3 times 2 is 6, and that makes that 11. So we now have 15 and 11. What do we do now? We are going to do element 2, 1. Second row, first column. So second row and first column. Right, so 5 and 3 pair together. So that's 5 times 3. And the 3 and the 4 pair together. 3 times 4. So 5 times 3 is 15. 3 times 4 is 12. And 15 plus 12 is 27. And there we go. And we are storming through this. So that was 15, 11, and 27. One more number to go. How do we do this? Well, we want row 2 and column 2. And so row 2 and column 2. Let's multiply those together. First times first. So 5 times 5 plus the second times the second. 3 times 2, which is 25, plus 6, which gives me the staggering value of 31. And there we go. 15, 11, 27, and 31. Elements are the key to this whole process. If you know the elements, it will tell you which row and which column to multiply together. And as long as you pair the numbers in the right place, you're going to be a gun at this. All right, so we can use the CAS to do this type of stuff, because this is a CAS course, of course. So what we can do is fire up our calculator. We can put it into our main mode, and then firing up our keyboard. If you are a Casio ClassPad user, obviously for the TI Inspire, slightly different, but I'm sure you are guns at this as well. Loading up, I think this was Maths 2, we then see that we have a number of matrices buttons. I'm going to hit this one here, which is going to do me a beautiful 2 by 2 matrix. And then actually I'm going to multiply two matrices together. So 1, 2, 3, 4 by 4, 6, 3, 7. And your calculator plonks out the value of 10, 20, 24, 46. Easy peasy, lemon squeezy. What I need you to realize is the multiplication order is very, very important, okay? I know that in maths, 2 times 3 and 3 times 2 are the same. We've been teaching you all the time, oh, you can swap the order of multiplication. Not with matrices, you can't. And what I want you to do is show you. So if you notice here, I've got the matrices as 1, 2, 3, 4 first. That gives me the answer we just expected. If I swap the order of the matrices, 4, 6, 3, 7 comes first, you'll notice we end up with a very different answer. Now, why is that important to me? Because later on, it's going to be useful to us. And again, here is an example where, if you remember, you can actually put these into memory. So again, I put 1, 2, 3, 4 into A, 4, 6, 3, 7 into B, and then I said, well, can you work out what A times B is and B times A? And again, it came back with the previous answers. Okay, so let's look at some examples which have been taken very kindly from the Cambridge Further Maths Unit 3 and 4 textbook. Thank you, Cambridge, for allowing me to use your examples. Awesome. So first question says, which of the following matrix products are defined? Now, if you remember, that's just asking us to do that row column thing and see whether the middle two numbers are the same. All right, so AB. So let's do that first. So AB, what's the order of A? It is 2 by 2. What's the order of B? Row is 2 by, row is 1 by 2. And so when we look at those two, are they the same? Nope. And in which case A, B is not defined. And we would write that in the exam. We wouldn't just put a kiss, you'd write not defined. Part B then, BC. So BC we know is row, 1 row by 2 columns, and C is 2 rows by 1 column. Are they the same? They are. So in which case that there is defined. And part C, what have we got here? AC. Well, we know A was a 2 by 2. We know C was a 2 by 1. Are the middle values the same? They are. And so again, these are defined. And remember, we can look at the outer values in each case, not in this one because it's obviously not defined, but we can look at the outer values in each case to try and work out what the order of our result would be. And so we're moving on, and basically it's the same question, but they've just made A actually work. So part A, or each of these says the following matrix products are defined. What is their order? So it wants to know what is the order of their result. So again, A, so this time they've got BA. So B is 1 row by 2 columns. A was a 2 by 2. They are defined because those two values are the same. And so in which case, the order of their result would be the outer two values, which is 1 by 2. Yep, why is that? Because 1 by 2. It even gives you the order of the answer. Part B, BC. B was a 1 by 2 and a C was a 2 by 1. So the middle values are the same, hence they are defined. And so my answer is going to be a 1 by 1. Moving on to part C. AC is equal to a 2 by 2. And what did we have? 2 by 1. The middle values are the same. And so my order there is going to be a 2 by 1. This stuff is awesome. Evaluate the matrix product AB, where A is this and B. So now what's the matrix product? Remember the word product just means times. They just want me to times them together. So first thing, let's just check. Is AB defined? Well, A is 1 row by 3 columns and B is 3 rows by 1 column. They are in fact defined and we're going to end up with a 1 by 1 result. Okie dokie. So let's just do this. 1, 3, 2. I'm going to multiply it by 2, 4, 1. And we're going to end up with a 1 by 1. What is the element? The element is 1, 1. And so first row, first column. Well, there is only 1 row and there is only 1 column. So that was nice and easy. But I would still check for each question. Scrolling up just a bit to give myself some room. So we now pair the numbers together. As you move across the row, you move down the column. And so what do we have? 1 and 2 get paired together. So that's going to be 1 times 2. We get the 3 and the 4 get paired together. 3 times 4. And then we get the 2 and the 1 get paired together. 2 times the 1. And then remember, you add all those results together. So we get 2 plus 12 plus 2, which gives me 12, 13, 14, 15, and 16 as my final answer. And the examples keep coming. Evaluate the matrix product AB, where A is 1, 0, 2, 3, and B is 2, 3. All right, we can do this. So we get 1, 0, 2, 3, multiplied by 2, 3. Let's just check. Can they be done? That's a 2 by 2. What is this? 2 rows by 1 column. Yes, it can be done. What is my resulting matrix going to be? It's going to be a 2 by 1. So a 2 by 1, which means we have element there is 1, 1, and this element here is 2, 1. So first row and first column. Let's do that one first. First row and first column, and we'll match the numbers. So we get 1 times 2 plus 0 times 3. All right, I'm not going to circle them anymore. I'm just going to leave that to you guys to just check that am I pairing the right way. So the 1 and 2 and the 0 and the 3. That gives me 2 plus 0, which gives me the value of 2. Remember, 0 times 3 is in fact 0. Please get that right. Next row by the first column. So in this situation, let's pair up the values. So we get 2 times 2 plus 3 times 3. 2 2s are 4, 3 3s are 9. Add those together, 9, 10, 11, 12, and 13. And there we go. We have evaluated our matrix product as 2, 13. Now, how do we use all this stuff in real life? Well, it's funny you should ask. Actually, there's an example from Cambridge again. Thank you, Cambridge. Now, in this situation, we've got to make sure that we get the information the right way around. I actually recorded this video previously and made 2 massive mistakes, which has led me to having to do the video again. Not your problem, mine, but good to know for you. Not really. Okay, so the following example says that matrix E gives the energy in kilojoules. So the energy in kilojoules consumed per minute when walking and running. Okay, T gives the time in minutes a person spends walking and running. So we've got the energy used in walking and running and the time that someone has spent walking and running. Okay, makes sense. Compute, yes, the matrix TE and gives the total energy consumed during the training session. So TE, they're giving you the order here. So we're having T times E. So that's 20, 40, multiplied by 25 and 40. All right, so again, remember, T is the time spent. So 20 minutes with 25 kilojoules per minute for walking and 40 minutes running and 40 kilojoules running. Now again, notice the order of these things, yes? Walking, running, walking, running. So we have to make sure the order of these numbers in our matrix actually correspond, right? So that's walk and run, walk and run. Now you can say, why is that important to me? It's coming up in later videos. Let's just check that we can actually do this. How many rows? 1 row and 2 columns. And that's got 2 rows and 1 column. Yes, they are the same. And the result is going to be a 1 by 1 matrix, which means I do 1 row, 1 column. So let's pair those numbers together. We get 20 times 25, and we're going to add that to 40 times 40. So 20 times 25, whew, that's challenging. So firing up my calculator, what do we get? We get 20 times 25, which gives me the staggering value of 500, plus 40 times 40, I know, is 1600. I don't know why I would know that. Add those together, it gives me 2100. So 2100 goes inside my brackets, and that tells me then the total energy consumed during my training session. The summing matrix is a random one from Barry. Basically, the summing matrix just is a row matrix or a column matrix with ones in it. And when you multiply them together, what you actually end up with is a sum of the rows or a sum of the columns. Now, I don't know about you, but looking at the examples I have here, that would probably be easier to do in my head. But Barry loves to throw this stuff at us, and so let's make sure we do what Barry wants. So use matrix multiplication to generate a matrix that displays the row sums of the matrix, that one. So we have what the matrix 1, 3, 0, 2, 6, 7, and 3, 0, and 1. Put my square bracket in there. So what we need to do is we need to display the row of the sums, or display row sums. Now basically what we do there is we multiply that by the row matrix 1, 1, 1. Why? Well, because watch what's going to happen now. So let's just check this can actually be done. It can. It's got a 3 by 3 and it's got a 3 by 1. So the middle values are in fact the same. That's going to give me a 3 by 1 result. 3 rows by 1 column. And let's see what happens when we multiply that row by that column. All right, so let's have a look and see what happens. 1, 3, 0. So 1 times 1 plus 3 times 1 plus 0 times 1, which gives me 1 plus 3 plus 0, which in fact gives me 4. And hopefully you can see that if I add all of those values along there, it is in fact going to give me 4. How to get the next number? I would do the second row times the first column. So scrolling up just a little bit gives me a value of 2 times 1 plus 6 times 1 plus 7 times 1, which gives me 2 plus 6 plus 7, 12, 13, 14, 15, which gives me 15. And I can tell you that the next row will in fact give me 4. All right, so that there is a row sum. That's how to do a sum of rows, by doing the column matrix after. How would I get a display the column series of that matrix there? Okay, so we now want to do the column sums of that matrix. Let's use a bit of room over here. So we've got, actually I'm going to draw my square brackets afterwards. I don't know why I keep doing that. 2, 0, 5, 6, minus 1, 2, minus 3, minus 2, and 4, 3. Okay, so when we look at the order of this matrix, we have how many rows? 2 by 5. Now we're trying to actually sum all of these columns together. So our answer would have to come out as 1 row and 5 columns, because we want to add these columns together. And there are 5 columns, so we need to make sure that we have 1 by 5. So now reversing this, how am I going to end up getting this? Well, we now know that that's got to be a 2 and that's got to be a 1. Why has it got to be a 2? Because those two middle values there have to match to make the multiplication the same. And we have to end up with a 1 by 5, which means that has to be a 1 and that needs to be a 5, which means I now need to multiply by a 1 by 2 matrix at the front. So bearing in mind the summing matrices are all 1s, so I want a 1 row by 2 columns. So that's going to be 1, 1. And this is now going to be 2, 0, 5, 6, minus 1, 2, minus 3, minus 2, 4, and 3. And then scrolling up just again, we are now going to multiply row by each of those columns. And let's just see what happens. So the first row by the first column is going to give me the value of 1 times 2 is 2. 1 times 0 is 0, that's going to give me 2. Yay! Now we're going to do the first row by the second column. So 1 times 5 plus 1 times 6 is going to give me 11. And as I keep going on, minus 1 plus 2 gives me 1. Minus 3 plus minus 2 gives me minus 5. And 4 plus 3 gives me 7. Now, what I showed you here with regards to reversing this order of multiplication, or getting the orders to match up to make my answer work, is freaking awesome and really, really important. Finally, this is the last part of the video. I'm sorry guys, I know it's 30 minutes long, but this is probably one of the most important videos for matrices at this time. Matrices can be used to solve simultaneous equations, and more are coming on this in the next major section on matrices in 2 or 3 videos time, so bear with me. But there are massive uses for matrices to solve simultaneous equations. So here we know are a pair of simultaneous equations. Remember those things from year 10 where we made you do them by elimination and substitution? No one mentioned matrices, did they? No. And I tend to think it's a little bit easier. So we can actually write these. We can actually write these values here as the product of 2 matrices. So I can change this, and I can take each of the numbers in front of the x and the y's and go 4, 2, 3, 2. Do you see where those values have come from? Scrolling in just a little bit or zooming in. 4, 2, 3, 2. So all I'm doing is taking those coefficients of each of the x and y's and putting them in a matrix, and then I'm going to put an x, y here, and I'm going to write an equal sign and 5, 2. Now where did I get the 5 and 2 from? 5 and 2 came from there. The x and the y, well basically this is my multiplication, because we need to get x's and y's into my equations by multiplication. So now let's check that actually when I multiply these together, I am going to end up with my final answer. So if you remember, we are going to check this with a 2 by 2, 2 rows by 1 column. And so yes, those work. Did it give me a 2 by 1 as a result? It absolutely did. Awesome. So now let's check that we can do this backwards. We are going to do 4, 2, 3, 2 multiplied by x, y. And as I say, this comes up in another video. Row by column. So we get 4 times x plus 2 times y. Hold on a minute. And now we're going to do row and column again. And we're going to end up with 3 times x plus 2 times y. And that becomes equal to the value of 5 and 2, because we told you that in this matrix here. Okay, guys, that was a lot to learn. If you need to, stop it, go back, rewind. The great part about doing videos is that you can watch it again and slow it down if you need to, or in fact, speed me up. I know some of my students play me at double speed. Weird. And there we go, guys. We are at the end of the video. Thank you so much for watching. It has been really, really good to see you. If you can, and you haven't already done so, head over to my YouTube channel and subscribe. It just lets me know people are watching, and it gives me a real buzz actually creating these videos if I know that people are watching. And it really does just mean you just click once, and the little bell notification to know when I upload new videos. It's been good. Thank you very much. I look forward to seeing you in another video. Until then, take care and stay safe.